All right, so 4.4, adding and subtracting rational expressions. So what we did last time, right, with a rational expression, so like, with things with x's and x squareds and all that kind of stuff, right? We were doing multiplying and dividing, right? So that was, for the most part, that was just simplifying. We factored and then we canceled what we could. So now what we're going to do is adding and subtracting, and it's a little bit more difficult because I don't know if you guys remember with fractions that when you have fractions, so something like this, if we had 2 over 3 plus, let's say, so 2 over 3 plus like 5 over 2 or something like that. Well, when you're adding fractions, remember, you can't just add straight across. It's not like multiplying. Multiplying was easy. You could just straight across. So when you're adding or subtracting fractions, the thing we need a common denominator, right? So in this example, what we do is we would say, okay, what number does 3 and 2 both go into? Okay, well, they both go into 6, right? So then I'd be like, okay, well, how do I turn this 3 into a 6? Well, I have to multiply it by 2. And then whatever I do at the bottom, I have to do at the top as well, right? So that's how the left term there would change. And the right side, I'd have to multiply that by 3 for both, right? And then what that would turn into is the top would be 2 times 2 is 4. The bottom would be 6 plus, and then 5 times 3 is 15 over 6. And then if you remember at this part, or at this point, the last step was we just add the tops or subtract the tops. If we were subtracting, that's all that would change, right? You just change that to subtraction. And then the denominator stays the same. So this would just be 4 plus 15, so 19 over 6, right? So now we're going to do that same thing, but with polynomials or with algebraic expressions, right? So let's give you an example. So let's say we had one like this. So we had, we'll call this, number 1. So we'll say 2 over 5x squared plus, and then we'll say 3 over 10x. And we have to add those things. Okay, well, what we need to figure out, just like the last one, is what do they both go into, right? Like, how do I make the bottoms the same for both? Because that's what we're going to do. We're going to have to make the denominators for both those terms the same. So I need to figure out, what does 5x squared and 10x both go into? And I'm really asking, what is the lowest common denominator, right? I'm asking, like, what is the LCD is often what it's called. So the lowest common denominator in this case would be, well, first off, let's just look at the 5 and the 10. So this will be the same thing as if, we were just adding fractions like normal. The 5 and the 10, let's just see, what do they both go into? Well, they both go into 10, right? Because I can multiply 5 by 2 to get 10, and I could multiply 10 by 1, I guess, if you like, to stay at 10, right? So I know that the lowest common denominator is going to be 10, right, for the numbers. And then if I look at the letters, if I look at my x's, so what do those x's both go into? Well, they would both go into x squared, right? They both go into x squared. And the reason for that is because I could multiply x by x again to get x squared, right? So it goes into that one as well. So hopefully this will make more sense in a second here. I'll show you as we turn it into this. I think it'll make more sense. So it's got to be 10x squared is what we're after, right? So that's what I want to turn this guy into. I want to turn that 5x squared in the denominator. I want to turn that into 10x squared, and I want to turn that 10x into 10x squared, right? Because once they're the same, then we can just add the tops. We can add the numerator. Okay, so I just need to figure out, what do I need to multiply by? So what do I need to multiply this 5x squared by to get it into 10x squared? Well, all I need to multiply by there is 2, right? That'll do it. But again, whatever I do to the bottom, I have to do to the top. Okay, so that part's done. 1 second. And then on the other side of this, I say, okay, what did I have to multiply this 10x by to get that to be 10x squared? Well, I had to multiply that by another x, right? Because 10x times x would be 10x squared, right? So again, I have to do that on the top and bottom. Okay, so now that we're at this point, let's just kind of clean it up for a second. Let's actually like multiply the top and the bottom here to see what we're dealing with. So this would be 2 times 2 is 4 over, and now the bottom is 2 times 5 is 10x squared, which is perfect because that's what we wanted it to be, right? That's what we were after. And then it's that plus, and then 3 times x is 3x over, and then 10x times x is again 10x squared, which again is perfect because I needed those two to be the same. I needed those denominators to be the same there. So now the next step here is just like what we did before. You can, well, we just need to write it. Well, the denominator stays the same, right? I know the bottom is going to be 10x squared, right? Because that's the way it was even when we were just dealing with normal fractions or typical fractions, right? But now the top is going to be 4 plus 3x. And I can't actually add 4, and like that's not 7x, right? Remember, when those are different, they're not like terms. I can't add 4 and 3x. So all we're left with, all we can do is just leave that as 4 plus 3x. And then there you go. That's us adding those original rational expressions. Okay? Hopefully you guys are kind of okay with that. I think this is going to be just a lot of examples, I think is what we need to do here. So let's do another one. Well, we're going to do a lot more, but let's do another one like this. So we've got 13 over x plus 1, and then times 2x minus 1. I'm going to make this one minus. And then we've got minus x over, and then we've got, let's say, 2x minus 1, and then x minus 1. All right, so now the question is, how do I turn them into the same thing, right? What's going to be my lowest common denominator, right? What's going to be the number that I put on the bottom, right? Like here, in the last one, it was 10x squared. What's it going to be in this case? And you'll notice the way that this is written, these have already been factored, right? These are already nice and in like their factors, right? And their own little chunks there. So I'm going to leave it that way. That's good. But now really the way you do these ones is if it shows up at all, right? Can you guys see that I've got like 2x minus 1 is there, and 2x minus 1 is there as well? So that's good. That actually means that that's going to be one of my terms in my lowest common denominator. So it'll be 2x minus 1 is going to show up down there. And then an x minus 1 shows up. So an x minus 1. And then also an x plus 1. An x plus 1, right? That shows up as well. So if it shows up, it's going to be down there, right? So that's what that's how we're going to do this. And what I can do now is, well, let's go back over here again and say, all right, what did I have to multiply that by to get this, right? To get that lowest common denominator, right? Well, to get that, it's really asking like, what's the thing I'm missing, right? I'm missing the x plus 1. I don't have that in here. So I have to multiply the bottom of this by x plus 1. But if I do that, I also have to multiply the top by x plus 1. Okay? So that'll do it for that side. Now let's go over here and say, what do we have to multiply by over here? Well, over here, I had to multiply it by x minus 1. And whatever I do at the bottom, I have to do at the top. So x minus 1. Okay. So now we just need to clean this mess up, right? So can you guys see that the bottom on both of these is the same, right? It's the same either way. They're in different orders. That doesn't actually matter, right? Because it doesn't matter what order you multiply things in, but they're the same terms there. So I can write that, I like to do it this way, like write that as my bottom right now. So I can say my bottom here is going to be 2x minus 1 and x minus 1 and x plus 1, right? That could be my denominator. And then I just need to clean up all of that, right? Because I actually need to subtract all of this stuff and actually do this. So let's make this a bit more clear. We'll write it again. So we've got x minus 1 times 13. I'm just going to write that for a second as 13 times x minus 1, just because that's kind of more typical to write the number out front. And then minus. And then it was really like this, right? It was minus, and then it might be helpful to put this in brackets. So it's minus, and then you've got minus x, and then times x plus 1. All right, so we've just got some things to clean up here. So I'm going to do in these brackets first. So I'm going to distribute that one in there. So we've got 13 times x minus 1 minus, and then you've got negative x squared, and then negative x times 1 is negative x. All over all of that stuff. 2x minus 1, x minus 1, and x plus 1. All right, now I'm going to distribute that guy in. So we'll go, so this is 13x minus 13. And then remember this next part here, this is really like negative 1 that I have sitting here, right? The minus part of it. So I'm going to distribute that one in as well. So now that'll be negative 1 times negative x squared. That'll be positive x squared. And then negative 1 times negative x, that's going to be positive x. And I promise we're almost done. 2x minus 1. This is all just the denominator again. So x minus 1 and x plus 1. Okay, then just for the top here, I just need to see, is there any like terms that I can collect, right? And there is. I've got an x and an x there that I can collect. So we can write this out again now as, I'll put the x squared term first. So it's going to be x squared, and then plus 13x plus x is 14x, and then minus 13. And that's all over 2x minus 1, x minus 1, and x plus 1. Phew. All right. Yeah, I'm kind of regretting I probably made this one a little bit tougher for one of the first ones than I should have. So sorry, guys. This is probably about as tough as they get. Maybe I'll go backwards a little bit, and I'll make it a little easier on you for now. So let's go backwards a little bit. Let's do one like, say 3 over 8x plus 5 over 12x squared. All right, so what is my common denominator, right? And I like to do it this way too. You could write out the common denominator like I did before, but the other thing that I'm going to do that I like doing is I'm just going to make the common denominator right now, right? Because I know that that's going to be the button or the thing that goes on the bottom here, right? So what do 8 and 12 both go into, right? What number do they both go into? Well, they both go into 24, right? So I know I can get to 24 with an 8, and I know I can get there with a 12 as well. So I know it's going to be 24. And then with the x's, the biggest exponent is really what I'm looking for here. That's going to be x squared, right? So that's what I'm after. That's going to be my common denominator there. So then I need to go back and say, okay, what did I multiply each of these by to get that? Well, on this one, I have to multiply 8 by 3 to get there. And I have to multiply the x by an x to get to the x squared. So it's going to be 3x on the bottom and 3x on the top. And then I'll move over here. And for this one, I just had to multiply by 2. That was it, right? If I multiply that by 2, that gets me there. And the top by 2. All right, so now, looking back over here, the top part here is 3 times 3 is 9x plus, and then 5 times 2 is 10. All right, and that's it. That'd be the answer. So yeah, so this is kind of a bit more typical. So if the last one kind of scared you, then don't. If you're doing better with this one, then yeah, you should feel good. Okay, let's do a few more. Yeah, let's do one like this. So So for this one, let's say we have 32 over x squared minus 16 plus 4 over x plus 4. All right, so now when it looks like this, when I've got like, you know, we're subtracting and we're adding, right? It's actually kind of hard to see what my common denominator, what my lowest common denominator is going to be here, right? Because in these ones, I wasn't adding or subtracting; they were multiplying, right? So I was able to just see, okay, what do they both go into, right? I'm not allowed to do that with, like, let's say the 4 and the 16, and the reason for it is because of this minus and this plus, right? I can't just do that. So here's what you always want to do. You always want to see what you can factor out first. Okay. So maybe you don't see it at first glance, but it's actually one of these easier ones if you recognize it. That's a difference of squares, right? That's x squared and that's 16 and I'm subtracting them. So that's difference of squares. So we can rewrite this as 32 over, and then the way we do these ones, write down both your brackets, and then square root of x squared is x, so they both get an x. And then with the difference of squares, right, with the minus, one's a minus, one's a plus, and then the square root of 16 is 4, so they both get a 4. Okay, so that's factor for that. And then plus 4 over x plus 4. So now it's a little easier to see what my lowest common denominator is here, right? I can see that, well, this one has a x minus 4 and an x plus 4, and this one has an x plus 4. So really the only thing I'm missing on this one is an x minus 4, and then they'd be exactly the same, right? So I know that my lowest common denominator, so I can write that down right now, is going to be x minus 4 and x plus 4. Okay, that's what they can both go into, right? I just need to change this one a little bit and it'll look exactly the same. So what we're going to do, I'm going to multiply the bottom of this one by what it's missing. It's missing an x minus 4. So I'm going to multiply it by x minus 4, right? And that should be in brackets like that. But okay, and then on the top would be the same thing, right? It also has to be an x minus 4. All right, so now my denominator is good. I just need to write out the numerator, right? The top here, right? So 32, so it's still going to be 32, and then plus, and there I'll write it once without expanding it yet. So we've got 32 plus 4x minus 4. And now that is right, but we just don't like leaving it, you know, in this awkward way like this. We want to expand what we can here. So let's expand that 4 into those brackets. So we're going to have 32 plus 4x minus 16. Okay. So now 32, well, here, now, and that's all over x minus 4, x plus 4. All right, so now the top one here, I can combine like terms. I've got 32 and negative 16, or it's 32 minus 16. So all of that would just become, well, let's write those. So that's going to be 4x, and then that would just be plus 16 now after I subtracted 16 over x minus 4, x plus 4. Now you're pretty much done here, but watch what's going to happen. I can factor something out here, right? This one has a 4 and a 16. So 4 goes into both of those. So I can factor out a 4. So I'm going to factor a 4 to that. So I'm going to say, okay, I'm going to rewrite the top as 4 and then start my bracket and then write what I have left. So it's going to be 4, and then that'll be x plus 4 over x minus 4, x plus 4. All right, so that worked out well, right? I've got an x plus 4 on the top and an x plus 4 on the bottom. Those guys get to cancel. And I'm just left with 4 over x minus 4. And that would be my final answer there for simplifying. All right. Now, I'm going to give you guys one. I'll just do one more. I'll do one more example and then we'll call it good. Okay, I'm actually going to give you guys an example of ones that are a couple that are on your. Actually, you know what? I'm going to do two. I'm going to give. Oh, they'll both be ones that are actually even on your assessment with just maybe slightly different numbers. Okay. So let's do this one. So we've got x squared plus 12x over x minus 6, and then minus 12x plus 36 over x minus 6. Okay, so when you see one of these, you guys should be happy because those are the same, right? So if those are the same, don't start multiplying it by things, trying to do like what we've been doing before. If those are the same, then let's actually just write that down. That's already a common denominator. So I can write that out. That is my common denominator, x minus 6. I don't need to multiply either side by anything. I just need to actually add the tops now. So the tops here, let's just write this out again. This will be x squared plus 12x minus, and then just really be careful here because this minus, right? This really is in brackets. So this is like minus, and then in brackets, 12x plus 36. Okay? So then let's, well, and why that matters is because now if I've got minus this stuff in brackets, it's going to change the signs on both of them. And you can also think about it as like distributing like a -1 into both. But either way, it's going to change the signs. So we've got x squared plus 12x minus 12x, and then minus 36. And then that's all over x minus 6. Okay, well, 12x minus 12x, those both cancel, right? That'd be 0. So I've got x squared minus 36 over x minus 6. And then you might be saying, okay, perfect, I'll put that answer in. Well, just be careful because I can factor that and it's going to do something for me. If I factor this, I can write that again, right? That's a difference of squares again. That'd be the same thing as x minus 6 and x plus 6. And that's all over x minus 6. All right, so then those are exactly the same. I can cancel x minus 6 and x minus 6. So this whole thing would become x plus 6 is all I'd have left.